Hello everybody, I am Mohammad Azhar Iqbal Nawalgund, Assistant Professor, Department of Physics, Government First Grade College, Mundargi. This is the 5th session on transient current and 15th session for the BSc 3rd Sem CBCS, the colleges of for the colleges which are affiliated to the Karnataka University. Today in this session we are going to study the discharging of a capacitor through the learning objectives. Theory for the growth and decay of current in RL circuit. Derive the equation for time constant during the growth and decay of current in RL circuit. Plot the graph of time against the current for growth and decay of current in RL circuit. Theory of charging and discharging of a capacitor through a resistor. Derive the equation for time constant during the charging and discharging of a capacitor through the resistor. Plot the graph of time against charge for charging and discharging of a capacitor through a resistor. Understand how to measure the high resistance of a resistor by leakage method. Problems on RL circuit, problems on RC circuit, as well as measurement of high resistance by leakage method. Session outcome. After studying this session, you will understand the theory and derivation of time constant equation for growth and decay of current in RL circuit, able to plot the graph of time against the current for growth and decay of current in RL circuit, understand the theory and derivation of time constant equation for charging and discharging of a capacitor through a resistor, able to plot the graph of time against charge for charging and discharging of a capacitor through a resistor, understand how to measure the high resistance of a resistor by leakage method, able to solve the problems on RL circuits, able to solve the problems on RC circuit, as well as measurement of high resistance. Prerequisites. Meaning of transient current, growth of current in RL circuit, equation of time constant for the growth of current in RL circuit, how to draw the graph for growth of current in RL circuit, decay of current in RL circuit, equation for the time constant decay of current in RL circuit, graph for decay of current in RL circuit, comparative graph for growth and decay of current in RL circuit, growth or charge in RC circuit, equation of time constant for growth or charge in RC circuit, graph for growth and discharging of charge in RC circuit. Decay of charge or discharging of a capacitor through the resistor. Now the capacitor is completely charged. Let the capacitor having the charge Q0 be now discharged. When the plug key is removed from the space between 1 and 3 and immediately closed the space between 2 and 3, the charge flows out of the capacitor and this constitutes a current. In this case, E is equal to 0. R into dq by dt plus q divided by C is equal to 0. Call this as equation number 1. Or dq by q is equal to minus of 1 divided by Cr into dt. Integrating the above equation. Log of q to the base E is equal to minus t divided by Cr plus k, where k is a constant. When t is equal to 0, q is equal to q0. Therefore, log of q0 to the base E is equal to k. Therefore, the above equation can be written as log of q to the base E is equal to minus t divided by Cr plus log of q0 to the base E. Log of q divided by q0 to the base E is equal to minus t divided by Cr. Or the above equation can be written as q divided by q0 into e raised to minus t divided by Cr. Or q is equal to q0 into e raised to minus t divided by Cr. Call this as equation number 2. This shows that the charge in the capacitor decays exponentially and becomes 0 after infinite interval of time. The rate of discharge is I is equal to dq by dt. That is equal to minus of q0 divided by Cr into e raised to minus t divided by Cr. That is equal to minus of q divided by Cr. Call this as equation number 3. The smaller the time constant Cr, the quicker is the discharge of the capacitor. In equation 2, if we put T is equal to Cr, then Q is equal to Q naught into e raised to minus 1. That is equal to 0.368 into Q naught. Hence, time constant may also be defined as the time taken by the current to fall from maximum to 0.368 of its maximum value. Decay of charge is as shown in the below figure. This is the discharging of the capacitor graph. As the time goes, the charge goes on decreasing and goes to a minimum steady state. Recap. In this session, we have studied decay or discharge of charge in RC circuit, equation of time constant for decay or discharge of charge in RC circuit, graph for decay or discharging of charge in RC circuit. On this session, we have some multiple choice questions. Question number 1. The expression for decay of current in RC circuit is option A, Q is equal to Q naught into e raised to minus T divided by Cr. Option B, Q is equal to Q naught into e raised to plus T divided by Cr. Option C, Q is equal to Q naught into e raised to minus RT divided by C. Option D, Q is equal to Q naught into e raised to minus of C into T divided by R. The correct option is option A, Q is equal to Q naught into e raised to minus T divided by Cr. Question number 2. The value of the time constant in RC circuit is option A, Cr, option B, R, option C, C divided by R, option D, C. The correct option is option A, Cr. Question number 3. The growth and decay curves in RC circuit are option A, overlap, option B, complementary, option C, straight line, option D, circular. The correct option is option B, complementary. The books which are referred for these sessions are Electricity and Magnetism by R. Murugesan, Electricity and Magnetism by Vasudev, Fundamentals of Electricity and Magnetism by Vasudev Ghosh, Electricity and Magnetism by B.S. Agrawal, Electricity and Magnetism by Brijlal and Subramaniam, Electricity and Magnetism by Sehgal and Chopra, Electricity and Magnetism by K.K. Tiwari. Thank you.